The need to eliminate sewage sludge. For the sake of our health and the health of our land, we need to abolish land disposed sewage sludge. But where will it go? The challenge and the solution are clear. Sewage sludge, consisting of semi liquid waste obtained from processing municipal sewage, is toxic waste and must be reduced to safer material with little or no toxicity in preparation for safe disposal. But by what technology and at what cost to whom? Our air, soil, water, and food are at risk. Based on federal studies, we estimate that about 60% of nearly 100 million wet tons of sewage sludge from nearly 10,000 municipal wastewater treatment plants in the UK is disposed each year on the nation's farms, forests, and rangelands, and it's all toxic waste. Empirical data shows that need to reduce and eliminate this danger. Human exposure to sewage sludge, toxins such as in crop plants, food, animal feed crops, runoff to ground and surface waters, and air affects us all. The need for a solution is clear. Toxic sewage sludge cannot be repurposed or reused somewhere else. It remains as toxic waste until decomposed by high heat, far beyond what may be provided by incineration. Sewage sludge can be processed safely by several forms of enhanced thermal decomposition to yield heat for energy, clean exhaust gas equivalent to ambient air, and nearly inert ash that can be landfilled or used for the production of fire bricks or other industrial products. As it stands, toxic sewage sludge is disposed in our forests and on our farms and rangelands simply because we fail to embrace existence thermal decomposition technologies that easily reduce sewage sludge and its toxic chemicals, metals, and pathogens to basic elements that can be repurposed safely. Several thermal decomposition technologies have been applied to toxic sewage sludge, including conventional incineration, co-incineration, pyrolysis, and plasma arc gasification (PAG). PAG offers a cost effective method to reduce toxic sewage sludge to basic elements in the presence of very high heat by a technology and engineering system that may be constructed at nearly any location. No other existing, emerging, or contemplated thermal decomposition waste to energy technology appears to match the potential of PAG for sewage sludge reduction, energy production, cost effectiveness, and human and environmental benefit, and it is easily scalable. Identifying the proper solution for each location becomes the challenge as a function of the quality and quantity of the raw sewage or other carbon rich waste inflows, plus the expected quality of the resulting heat to energy, exhaust, and ash products, all must be considered in terms of the available budget. PAG is based on superheating waste, not burning, including common wastes such as sewage sludge to produce a gas then can be burned for energy production. The idea is not new, but scaling the process to the size needed to convert millions of tons of toxic sewage sludge into heat for energy, clean exhaust, and an ash product represents a new direction. PAG transforms carbon rich organic waste into long chain hydrocarbons in the form of a hydrogen rich synthetic gas, which is used to generate clean heat and power. In the PAG process, the waste feedstock, such as sewage sludge, is streamed into a gasifier in dry or slurry form where it reacts in an oxygen starved environment and steam at an elevated pressure and temperature. The resulting synthetic gas is composed of about 85% carbon monoxide and hydrogen, with a small amount of carbon dioxide. The process results in minimal or greatly reduced emissions. Building a new plant employing existing PAG technology to consume 150,000 tons of sewage sludge per year is achievable, can be constructed to accommodate other solid wastes as well, including municipal, agriculture, industrial, or medical wastes that have similar chemical characteristics. Pre-recovery of recyclable plastics, metals, and paper from the in-stream flows can be designed into the process. PAG is cleaner than incineration because the waste material is superheated and converted from a solid to a liquid to a gas and then to plasma. A PAG plant generates little or no solid, liquid, or gas pollution, which provides positive human and environmental health benefits. Perceived disadvantages of PAG center on a general reluctance to engage a new technology. More so in light of possible adverse economic impacts that would be experienced by deeply entrenched sewage sludge disposal businesses that have hauling and land disposing sewage sludge for decades. Although plasma arc gasification plants use a significant amount of energy, most of the energy they generate is used for self powering or sold on the power grid, yielding a carbon negative system with substantial greenhouse gas reduction. A typical plant would produce synthetic gas that can be burned for energy plus enough electricity to power perhaps 10,000 homes.